Hello, this is part 2 of Damaged Amiga 2000 video. The machine was damaged in shipping and had other unfortunate adventures which rendered it inoperable. In part 1 I have identified two Zorro cards which blocked Zorro autoconfig process. In this video I will try to repair these cards and fix rest of the problems. So let's start. So here I have these two suspected cards. I think I just need to test if we have any bad chips here. So I have already removed from both cards, as the design is similar in both cases. So they have these two bus transceivers here, 74245s. And I will test them using my custom chip tester, and we'll see if they're good. So you may ask why I decided to start with these bus transceiver ICs. Well, two of them, U14 and U15, are providing card separation and signal conditioning for the data lines of the Zorro bus, and are directly connected to the data lines on the bus. They are also relatively easy to check, and from a quick look on a schematic, it seemed that they could be exposed to at least minus 12 volts from the bus when the card was inserted backwards. I have already wired the tester for 74245, and I have also written a test for this chip. And now let's see if these chips are good or not. So let's fire up the tester. And here is the test that I wrote for this chip. So basically this tester allows me to write tests for different ICs. So such a test basically has a pin definition for the IC pins, so I can assign a particular pin on a tester a name and then use these names in the test, and then I'm able to define test frames where tester will basically set lines to some defined values and read back values from read banks. And then in the end there is a test criteria which is checked against basically the results read from the chip are tested, checked against this criteria, and that's the actual result of the test. So let's load this test. Okay. So already first chip did not pass the test. Okay, maybe let's see. Let's see the state table for the test. Basically a state table is a place where we can see what was sent to the chip and what was read back from the chip. So we had, this test had like 512 frames. Unfortunately I don't have currently any way to stop this listing, so it will have to go to the end. And then we can just take a look at the results and see what can be wrong there. So bank 2 is set as a read bank. Bank 3 and 4 are write banks. So basically these two pins 30 and 31, these are the direction and enable pins. So direction is set to 1 for 74 245. This is A to B transceiver. Pin 31 is set to 0 to state low. This enables the chip. So basically we should have what we have on input bitwise, we should all have the same value on output. So we see that there is a bit that is constantly set to high. Even if we have all zeros on input, we still have this one bit set to high and to 1 on output. The rest of bits seem to reflect input value. So obviously we have one failed buffer line in this chip. Okay, so let's take another one. So this one seems to be bad. Let's just take this and let's run the test. Oh, this one is good. There are no issues with this one. So this one we can mark. Check these three. This is good. This one is also bad. And this is good. So we have two bad chips, one from each card. So I will have to order these because I don't have them right now. I will replace them and we will see if this is the only issue or maybe there are some other damaged chips. Okay, so now let's test this card. So this chip is replaced. I have checked both of these and they are now in sockets. And let's see if this card will work now. So I have booted the computer from a GoTech Auto boot, and let's select a test kit ADF. Maybe here. Okay. And now let's boot from it. Okay. Okay, so we have 5 meg visible now. So there's 1 meg of onboard memory, which is divided into 2 halves. This I don't know why, but that's how it looks. So we have a half meg here, and 4 megs of a fast memory, which are 2 Zoro cards. So the full size card which I have checked before. It was good. So this is a 2 meg card, and there is also a card that I have fixed, I think, successfully. So let's test all memory. And let's see if there will be some errors or not. So this scan converter which I use is absolutely horrible. It's a potato quality image, but that's all I have. Okay, so we have 3 rounds and it seems to work. So I think we can safely assume that the memory card is fixed. So all it was burnt on the card was one chip, 74LS245 bus transceiver. After replacing it, the card is working okay. So now let's try this controller. Okay, so maybe I will take this card out. I'll put this one in. Okay, so let's try to enter the early board diagnostics and boot monitor. Let's see if this card is visible. Expansion board diagnostics. And we have 3 working cards, which is good, because previously I haven't shown this on camera, but both of these short cards, which were suspected cards, which were inserted backwards, they were not showing up here. Only the full-size cards, so the bridge card and the memory card, I was able to see them here, both short ones. So memory card and this controller, they're basically not showing up here. So this controller is showing up here now. So let's connect the ribbon cable and compact flash drive, and let's see what will happen then. So I have the original card that came with this computer. Let's see if this will work. So let's try to boot from test kit. Okay. We don't have any hard disk test here. Okay, so maybe let's try to boot from Workbench install disk. So I will now try to boot from a Workbench install disk and use HDinst tool to try and detect the card. So I'm booting from Gotek now. Okay, so this is a Workbench install disk mounted in Gotek. So HD tools, HD toolbox. Okay, so unfortunately this card is not detected, and for some reason it's the LED, the activity LED is basically lit all the time, so it's hard to tell. Maybe this controller is still bad, maybe there are more chips broken there. So that's unfortunate. Okay, so maybe I will try a different compact flash card. Let's see. Okay, so with this card, the LED is off. So it's acting differently. We are booting from GoTech. A Workbench install disk. So let's see now if this card will be detected. No, unfortunately this other card that I know that it should be okay. It's also not detected. But the controller seems to act differently as with the other card. This LED is constantly on, and with this card the LED is off. So maybe there are more bad chips on this controller. I will have to check the other ones. So what other chips do we have on this controller? Except three 74LS245 bus transceivers, we have two 74 series chips. 74LS6A8 8-bit comparator and 74LS373 8-bit latched register. Both of these chips are part of the card address decoding logic. When the card I/O address is relocated by kickstart during autoconfig, new address is written to the 74LS373 register, and it sets an address value for 74LS688 comparator, which will trigger card logic whenever the card is addressed. Apart from stock 74LS series, we have 5 programmable GAL chips, which are actual controller logic, and a ROM containing card firmware. I have written tests to verify both 74 series chips and found them to be good. So next step had to be to validate the rest of the ICs, that is all GALs and a ROM. This card, AT-Bus 2008 clone, is designed by Matthias Heinrichs, aka Matze. And all of the card information and schematics, GAD files for GALs and a ROM image are made available free of charge by Matze on German Amiga forum a1k.org. I have downloaded all card information and decided to program all new GAL chips and compare ROM dumped from the card with image from a1k.org. So here I am programming new GALs for the controller. GAL fuse maps from original chips were dumped, and they seemed to be the same as ones published on a1k.org. ROM was also verified and found to be the same as image published on a1k.org. Still, even if all the chips seemed to be good, I have decided to replace at least all the GALs with a new, freshly programmed ones. So unfortunately, even after replacing all the GAL chips, known good ones, after checking the ROM, which I have damped, and it indeed contains an octopus ROM, so I also did a binary comparison of the ROM dump from this card with a ROM provided by Matze on a1k.org, and they're exactly the same. So the ROM is good, all 74 series chips are good, all GAL chips are good, they were replaced with freshly programmed ones. We still can't detect compact flash card. So we'll have to ask around on the internet, because yeah, I'm at loss. I just don't know Amiga all that well. I don't know if this card should have any drivers loaded, and maybe then it will be able to detect the compact flash card, or what. There are no failed parts on it, everything was checked. I have also checked all the capacitors for shorts. There are no shorts, all the chips are good, and it's still not able to detect compact flash card. So I have created a Reddit thread on r/Amiga, and I got quite a good directions from the people there. So they told me to abandon the flash card, because the Amiga probably is very picky about the cards that it will work with, and just try an old ATA hard drive, and that's what I did, and voila, the disk was detected right away and I was able to install the system on it. Now I'm able to boot computer from this drive. Okay, so I think I can consider this controller fixed also. So only thing that was actually broken there was exactly as on this card. It was only one 74 LS245 bus transceiver. So on both of these cards there was a 1-bit chip, and now they're both fixed, which is great. So only thing I have to do now is to glue the panel, check the floppies, and put the system back together. So both damaged cards are fixed. Currently I don't have a compact flash card that would work with this system, so I will leave the hard drive for now inside until my friend will be able to find a working compact flash card, and he will just then replace it for himself probably. So this floppy drive, it was not accepting disks, so I was not able to put the floppy disk all the way in. Now it's working. So the problem was that this metal case was basically jamming with this lever. This is visible here. There is a small lever there, and this lever was jamming with the case that was bent a bit, so I had to straighten the case, and now the floppy works without problems. Unfortunately, this other floppy that was missing the cover, so I was able to reattach the cover, and also I have 3D printed a new button which was missing, but unfortunately this floppy doesn't work. It's not reading the disks at all, so I'm leaving it out for now, and I have replaced it with a brand new Alps PC floppy converted to an Amiga DD type floppy. And I have also 3D printed this little spacer, basically to hide the gap, because of course these PC floppies are smaller than Amiga ones. And I have also glued this lever, so it seems to be holding fairly well. And also the same for the case. I have glued the panel with an epoxy glue. It's not pretty, but it seems to hold quite well. So yeah, the system is more or less ready to be put together and do a final test. Okay, so the system is assembled. That's how it looks now with this PC floppy. It's not great, but it's also not terrible, and for now it will have to do. Okay, so maybe let's run it and let's go into a boot monitor. So I'm holding the both mouse keys. Let's see. So we have 4 good cards. So there is a bridge board, 1 full-size RAM expansion card with 2 megs on board, memory master card also with 2 megs, and a disk controller. So computer is once again without its cover. So I decided to test bridgeboard, and as I don't have any Amiga floppies, I will have to use Gotek to load the drivers. Okay, so I've installed the application software here in the PC drawer, and when we will run a PC color, we will get a PC window, and it seems to be trying to read this 5¼ inch drive floppy disk. As there is no floppy there, of course there is a boot filer. If we would have a boot floppy with some early DOS version, we would probably be able to boot a DOS on this card. So I think we can assume that the card is working. So in the process of repairing this computer, I have used a few very helpful web pages, which I would like to mention now. This is an Amiga post, which contains a lot of useful information needed to convert Alps DF354H floppy drive to an Amiga DD type, with pictures and every information needed. This is a post on a1k.org made by Matze, announcing the release of ATBus 2008 clone card. So there's everything needed to basically build your own copy of this card. So GAD files, ROMs, schematics, bill of materials, high quality pictures, and everything that you need to build or diagnose such a card. And here is a great article from techtravels.org blog, from which I have learned a lot about the Amiga autoconfig process, addresses, chips used, bus transactions, and a lot of other info which allowed me to understand the process well enough to troubleshoot it. So that's it for this video. Computer is more or less fixed and ready to be returned to its owner. Thanks for watching. Until the next one. Bye bye.